So we're going to talk about array functions. We're going to begin by defining what an array is. And then we're going to look at 4 functions in Excel that are innately programmed to handle arrays, beginning with the sum product function, which generates a single result, the transpose function, which generates an array as a result, the index function, which allows you to handle 2-dimensional arrays, the lookup function, which is more efficient to use actually than the Vlookup function, but you have to sort your data, the aggregate function, which in some cases allows you to use arrays, in some cases not, the sum function, which is an example of a function that will allow you to define some of the arguments by using arrays, and the Vlookup function, which is an example of a function that you can convert to an array function by using CTRL+SHIFT+ENTER. So we have a lot to talk about, beginning with what an array is. An array is a collection of more than one object, or 2 or more objects. So an array function is a function that handles not a single cell reference, but a group of cells, a range of cells. The sum product function is an example of one of those functions that's programmed to handle arrays. In fact, the arguments are defined to be arrays, array 1, 2, 3, and so on. What the sum product function does is it multiplies one array times another array, or 3 or 4 arrays, and then adds the result. So I've got a sum product function in this cell that looks similar to how you would use it if you define 2 arrays. That formula is exactly the equivalent of this formula, which has 2 array constants, and each one of these array constants equals the array being referenced in the formula above. So the first array has as values 6, 4, and 12, and the second array has as values 10, 40, and 6. They're just hard-coded in this second version of the sum product function. That's the equivalent of multiplying 6 times 10 plus 4 times 40 plus 12 times 6, which is the equivalent of 60 plus 160 plus 72, and added together is the 292. So if we were to put a sum product function in a cell, we would reference the first array, comma, the second array, and if we only have 2, we'd close the formula with the parentheses, and there's our 292. So the sum product function generates a result in a single cell. The transpose function is also designed to handle arrays, programmed that way, but it gives you a resultant array is what it's called. And that resultant array is generated from the function, and it is displayed in more than one cell. So when you take a look at the transpose function in these 3 cells, you'll notice a couple of things. First off, that there's curly brackets around the transpose function. That designates this as an array function. But you don't manually insert those curly brackets. You put the curly brackets in by pressing CTRL+SHIFT+ENTER, and we're going to do that in a second. The other thing you'll notice, and you have to go to another cell to notice this, is the transpose function is exactly the same in all 3 of these cells. So to input a transpose function, you first have to select a number of cells equal to the area that you're going to transpose. And the transpose function will take a vertical-oriented series of data, or a range, and convert it to a horizontal, or vice versa. In this case, we have a 1-dimensional array. It's a column of 3 cells, so I've selected 3 cells to put the resultant array into. I'm going to input the transpose function, select those 3 cells that I want to transpose, and press CTRL+SHIFT+ENTER, and I get my result. I get my curly brackets. And the thing about an array function that's generating a resultant array that's in more than one cell is it's sort of a unified whole, and you can't change a piece of it. So if I try to delete that cell, I get an error message. If I try to Control-X, copy and paste, I get an error message. And you can actually convert a regular function to an array function if you want to make sure that people aren't going to change that grouping of cells. You don't want to use the protection mechanisms that are available in Excel. The third function we want to talk about is the index function. The index function, as well as the transpose function, will handle more than one-dimensional array, a two-dimensional array. The first argument in the index function is an array, and then it asks you for the row number and optionally the column number within that array, and that is the data that you're going to pull out, and that's going to be the result of this function. So when I go to this cell, I've got the array defined to be the area that's visible there. It's row number 3 and column number 3. So we're going to begin in this cell and go down 1, 2, 3 rows and over 1, 2, 3 columns. And the index function generates B2 as a result. The thing about array functions, and other functions for that matter, is you can press F2, select one of the arguments, go down to the listing of the arguments below the function, select that, and press F9, and have that argument or that selected piece of the function or formula calculated. When you do this, if you don't press Ctrl-Z to undo it, you'll convert what is an array reference to an array constant, because that's what we'll be left with in the formula. It's just what you see. So I'm going to press Ctrl-Z to undo that, because we have that displayed in this second version of the index function, the array constant. For two-dimensional arrays, the syntax that's used to define a two-dimensional array is when you see a comma, you're going to move a column over to the right. When you see a semicolon, you're going to move a row down. With those two punctuations, the two-dimensional array is defined within that array constant that we have in the second version of this index function. The lookup function is a fourth example of a function that is innately programmed to handle arrays. The area that we're looking in, the array that we're looking in, is there, and the lookup function will work if you sort your data, because it works exactly the same as a Vlookup function that's looking for a close match. So you can create bins or data groupings, basically, where A is found in the first cell, because A is actually in the array. B is above A but below C, so it's going to give A as a result. And C is actually a data point in the array. And D, again, is above C but below F. And the lookup returns a value of C. And that's exactly the same values that you get using a Vlookup, with option 1 being used as the range lookup. The aggregate function allows you, in some cases, to define the arguments using arrays. I'm going to input the aggregate function, just as you see it here, into this cell. There are 19 different calculations that can be performed using the aggregate function. These options are numbered, and numbers 14 to 19 allows you to define the arguments as being arrays. So the aggregate function will innately allow you to define arguments as being arrays as long as you're using the calculation options 14 through 19. So I'm going to use 14. I'm going to ignore nothing. The array is B6 to B8, and K is the number within that array that I want returned. So I'm going to return the second cell, close the parentheses, and we get our result of 6. The sum function is an example of a function that allows you to define some of the arguments as arrays. So we've got the sum function displayed there that equals what you see as far as the text version of that to the right of that cell. And when we input that into another cell, what it looks like is selecting one array plus another array, close the parentheses, and we get our 12. So it's 1 plus 2 plus 3, which is 6, plus the same numbers again, which is 6, which equals 12. So we were able to use the sum function as an array function without pressing Ctrl+SHIFT+ENTER. The Vlookup function can be converted to an array function by pressing Ctrl+SHIFT+ENTER. I also have an array constant in this Vlookup function. So we are looking up this value, Sam, in this array, and what I want the Vlookup function to give to me is the first, second, and third column. So there's several things going on here. We have an array constant in the Vlookup function defined as the column reference. We've converted this Vlookup function to an array function by pressing CTRL+SHIFT+ENTER, and the resultant array spans 3 cells because I want columns 1, 2, and 3. So when I set this up, I need to select 3 cells, input the Vlookup function. We're looking up Sam in this range, and I'm going to input an array constant 1, 2, and 3, and the last argument is going to be false. CTRL+SHIFT+ENTER, and we get the same results as we did here. So that's an introduction to array formulas or array functions. We defined what an array was. We looked at 4 functions that are innately programmed to handle arrays: the sum product, the transpose, index, and lookup function. And then we looked at 3 functions as other examples of functions that, one, the aggregate function, allows both arrays and not; the sum function, which allows you to define some of the arguments as arrays; and the Vlookup function, which we converted to an array function by pressing CTRL+SHIFT+ENTER. There's a whole lot more you can do with array functions. This is sort of scratching the surface, and we're going to get into a lot of the functionality with arrays in the subsequent movies.